Thanks for attending my talk. It's sometimes thankful to have me talk after the lunch break, sometimes not. I hope you guys are not going to fall asleep. And this is going to be, as Jed already said, a story about how PayPal slowly transforms into this new and better company that started to adopt technology stacks like Node and lots of other cool things like Go. And I hope that you guys are getting something out of it. I try to leave some time for Q&A, so let's see. And most good stories usually start with a little bit of background, right? That's like one of those movies where you go back in time, and if you go back in time, it shows where all the characters come from and why the current situation actually exists. So PayPal got founded in 1998 as a company called Cofinity. And back then in Silicon Valley, everybody had one of those PDA pages. Anyone ever owned a Palm? Okay, so those things used to communicate via infrared. And a few guys, including Peter Thiel, who's nowadays this enormous investor, thought it would be enormously awesome if you could send money around using infrared. And, well, it didn't really work out. So they started a new product and another new product. And in 1999, 1 year after they founded the company, they came up with a product called PayPal because they realized sending around money in the web is not really easy. So 2000, a company called X.com, ran by Elon Musk, the awesome guy who runs Tesla nowadays, acquired them. And then in 2002, they got acquired by eBay. So a lot of different history, and as long as they exist, basically being one of those kind of oldish companies in Silicon Valley nowadays, they had a bunch of different engineers coming and going, starting stuff, nearly finishing it. Sometimes they did, sometimes not. So you can imagine the technology stack is kind of a mess. And sometimes, if I think about these scenes, I imagine this all graying out, a sad trombone. So if you think about Jake Archibald with his sounds, I should have totally done that. And the traditional application stacks that PayPal had were basically two, and that's what we had till up a few years. So the first stack was a traditional C++ stack, because obviously a lot of stuff that we do is very processing heavy. And then there is Java, which used to do a lot of the web apps hosting based on Java with Spring, JEE, traditional. And it was kind of effective for a while, and our teams basically knew how to scale those applications. But you cannot scale any application till infinity. And obviously, nowadays, nobody really likes to touch these things anymore. And if I look into this room, and usually I give this talk in front of a JavaScript audience, everybody looks kind of like that. People are disgusted. C++, Java, well, obviously not what we all want to go for. I have to be honest, I used to be a Java engineer, so please bear with me. Now, this is PayPal in 2002, and we used to have this big problem where we had deployments every 6 weeks. And now, if you imagine issues like there's this number saying we have 100 million users, and this number changes, we have to wait 6 weeks until we can deploy these things. And you can imagine how painful that is. And it was not just the website that got deployed every 6 weeks. It was also applying to our API. So if something went wrong in our API, you had to wait 6 weeks until you could actually fix it. And obviously, going forward into our modern kind of engineering culture where we do continuous deployment and continuous integration and so on, this was really, really awkward for our engineers because we had those engineers working on different stacks, and they realized that it is incredibly painful to work on our product. Because on the one hand, we used to have our production stack, as I said, 6 weeks of deployment cycles and so on. And then on the other hand, we do have the prototyping stack. And that's where our developers usually went along and had modern scripting languages, lots of stuff happening in JavaScript, sometimes Ruby. And those guys were able to basically come up with new functionality incredibly fast. And they used modern kind of toolkits like Bootstrap and Bower and so on. And then they had to roll it out into our regular stack. They had to do a port. So instead of just taking the JavaScript templates that you just wrote and all the CSS awesomeness, they had to come up with ways to bring that to our stack. And I'm going into the stack in a second. So we had user testing, we had A/B tests, we knew what people liked, and then we had to wait 6 weeks again, at least, to roll these features out. And we don't really interact with full-stack engineers on the production stack. So you had the traditional Java backend guy and the traditional HTML kind of web developer. And those guys didn't really talk to each other. So a lot of those reasons basically lead to huge problems, obviously. So the situation we were in at that moment was actually kind of frustrating. We had the C++ stack with style sheets for XML. We had Java backend with JSP. As I said, mostly was based on Spring. And then we had this cool prototyping stack that I usually just define as nodes with different JavaScript templates. And we tried out a lot of those different templating languages, and at one moment, actually, the big decision came that we should go for Dust, which is heavily driven by LinkedIn. And people at PayPal just started to adopt it and kind of liked it. I'm going into a few reasons for Dust in a few minutes. But to be honest, it's not really about the templating language as it's, in general. It's more about JavaScript templating. So we had this big issue with our Java stack, right, where I'm saying we were running JSP. But before we had JSP, we were even writing our HTML, CSS, and JavaScript in Java. So it wasn't even JSP pages that were rendered, but also. Now, a big problem with JSP is that you usually end up with a lot of different programming languages and scripting languages and markup languages in one file. Because you can have HTML in a JSP file, CSS, JavaScript, and Java. So obviously, it was a big mess, and we had to get rid of that. So a few people came up with a UI toolkit at PayPal that they called Spartan. And Spartan was a proprietary solution based on Spring. Nowadays, we would do that whole thing different. Now, a big issue with proprietary software is usually that you have a bigger ramp-up time if you bring in new engineers, because those engineers have to learn about the frameworks, have to apply those frameworks. We had those really bad deployment cycles, so people were not happy. Now, there was gladly a big push into open source. A lot of great new engineers came into our companies. They used to work for startups before or other bigger companies. And they said that open source might be actually something valuable to pursue. So 3 reasons why you might want to go for open source in a company. As I said, less ramp-up time for your engineers. They can usually work with the tools that they know anyway. So they are more efficient in just doing work on the toolsets that they know already. Then there's this big issue where engineers often have to focus on setting up environments and setting up the project and all that stuff instead of actually building the app. You want that your engineers can build what you want to achieve and not have to do all the setup work, because that's less efficient, obviously, and you waste a lot of time. And then, obviously, the last reason is proprietary solutions are seldom better than the open source ones. There are great open source projects out there with thousands and hundreds of thousands of committers. So why don't you just go for that and try to bring some benefit into that? So we came up with rapid deployment and development cycles, and everything was great, right? On our production stack, we still had to go with the old stuff. So we ended up with a push into going into a new production stack. And this all was still before we introduced Node.js. So we had Bootstrap in the front end, we had JavaScript templating, as I said. And then if you want to go for our regular stacks, I said that we have C++ and Java. So what we did is we injected the C++ V8 engine into our C++ stack. That was fairly easy. We call that the project DeLorean. So if you remember DeLorean from the Back to the Future, it's that awesome car that does the time jumping stuff. So we thought it was kind of a fit. And then there is Mozilla's Rhino, which is a full JavaScript implementation in Java. So that's what we used on our Java stack to run the different templates. And looking at that, basically we had now a few different kind of environments. Again, prototyping, we went with Dust, and it was great. Now, since we settled on using Dust also on our Java stack, we leveraged Rhino, and we were able to run the same templates that we wrote for our prototyping stack on production as well. And that was obviously great for us because it helped us to not leave the old stacks behind. Because if you want to push for new apps, it's obviously an easy choice to say we want to go for Node and we want to go for awesome JavaScript templates, and we leave the old stuff behind. But since we have so many different applications, that was not really something that we could do. So we wanted to try out Node in production. And this one thought, this one wish came from a simple project. PayPal checkout page that you might know if you go and buy something online and it redirects you to PayPal generates more than $3.5 billion every year. And we thought, why not start at the core of PayPal, at the one thing that drives most of our revenue? So a project got named after the god Hermes, got born. And Hermes is the god of agility and mobility. So what we did is we started with a very simple stack that we just introduced at the beginning of that week. So we had Node.js running, we used Bootstrap to do some very lean UI, and we used some other open source. As I mentioned, we used Bower. And the first prototype of the new checkout platform was born in 3 days. And people were incredibly excited because we didn't have to fiddle around with our old frameworks. It was much easier for new engineers to get involved. So that was great. And then we thought we should definitely try this with another project. And that's the account page, the PayPal wallet app. So if you go to PayPal and log in over there and you see your balance and your funding sources and all that stuff, that is actually the first project that we did. And it's actually kind of risk to go for a new platform in production if you're not sure that it's really running. So what we did is we had first this initial project with the checkout page, and people were convinced we should try it, right? So we had 2 teams starting with 2 projects. The first team was a traditional Java team that was used to our stack and was well trained in actually building apps on this stack. The second team was only 2 JavaScript engineers compared to 5 Java engineers. And they were supposed to just give it a try and build the same kind of experience. So we started in January in 2013. And the Java team obviously used the existing components and started building the app. In March, just 2 months after, the environment for Node was completely set up. So we had key stores, we had logging services, we knew how to connect to our databases and so on. So that's what we 2 engineers built on JavaScript. Now, in June, the 2 teams met crossroads. So in terms of functionality, both applications were on par. One team, 5 Java engineers, started with all the existing services. The other team was just 2 Node engineers. So we ran a few functionality tests, and all of them passed. And we were actually really convinced that this is a good sign and ran a few benchmarks. So I don't want to bore you too much with numbers, but just to quickly go into it, we have a bunch of different requests with number of users. And this is the Java stack. And you see the Java stack actually averages at some point at about 11 pages per second, starting with 1 user per request. And then we go higher up to 15 users that request at the same time. Now, this is 5 cores for actually production hardware that we are using. And then we had the Node stack. And the Node stack actually serves nearly double the requests. And the same stuff happens just on 1 core at that moment. So it was a very young new stack. It was barely optimized, and it was more efficient straight away. Obviously, you cannot really compare apples to peaches. So it's not completely fair to compare those 2, because one is using our proprietary Java kind of stack, the other not. But at least for us, it was a good sign that we could go ahead with this. A few more numbers that we had were pretty much the code was actually very lean. We had to write less code to achieve the same. And we needed less engineers to do the same work. So we were kind of convinced to go ahead. Now, our Java engineers gladly were not so negative about it, started to contribute to parallel work streams, and got taught to get some more Node skills and JavaScript skills. Now, the new stack at PayPal changed over, and what we have right now is C++, we have Java serving some older apps, and all the new apps running Node. And I think the biggest step into this direction for us was actually decoupling our UI first. Because obviously, if your application layer and the UI layer are really tightly integrated, it's very, very hard for you to iterate and go ahead and start a new stack. So now that we are able to run Dust on all those 3 different stacks, we can basically bring all new features to all stacks, which is amazing for us. Now, since we do JavaScript templating, it comes with the big benefit that we can render both on the client side and the server side. And we actually use that quite a lot. So what you will see if you go to PayPal.com, the initial start page is always rendered on server side, and then for dynamic content, we can decide on the fly if we want to render that ahead or just when the client really loads it up. So one of the benefits of Node is obviously the Node package manager, and we use it heavily to actually distribute our internal services. So if we want to use our monitoring services, security, anything that actually interacts with our C++ tech, we can just go ahead and install some NPM modules. And we're using an internal NPM proxy for that, which I will show in a few seconds as well. Now we had this situation, we were finally able to start and actually go ahead and use Node, and we had Dust, and everything was great, right? So for us, this was the moment to release the Kraken. And the animation you just saw took me about half an hour. So please bear with me, I'm a developer. So with Kraken, we actually had this one situation where a lot of different teams have been working on Node. They leveraged Express. We used Harpy, lots of different kind of ways to build our service. And a few best practices actually started together. So Kraken is a suite on top of Express. It's not a whole framework. I wouldn't call it framework. And it comes with a lot of kind of sensible defaults, a lot of pre-configured stuff that makes sense. So as I said, we used Dust for templating, but it doesn't necessarily have to be Dust. So if you like Jade or if you like EJS or anything else, you can just go ahead and use that. And originally, it was made to make middle-scaled to corporate-scaled companies adopt Node faster. But we actually noticed that lots of startups started using Dust and started using Kraken because they didn't have to care about security and a lot of other stuff. And it heavily taps into middleware, which obviously comes both with Express and Kraken at that moment. Now, the reason is, as I said, lots of different teams at PayPal are working on the same kind of stacks, and they build different apps. Now, if you have a lot of teams building apps in the same frameworks or different frameworks, you will realize that everybody configures frameworks differently. If you have now engineers moving from one project into another, they're kind of lost because configuration is made different. Some of them might use some JSON files for configuration. Some of them use some methods to initialize things. So it was a big mess, and we tried to resolve that by bringing some best practices into that. And now, I already said it before, they have actually more time to build projects instead of just setting up the environments, which is really good for us. The project structure is actually kind of opinionated. So we try to push for a clear model view controller way, and we used that initially by having kind of different frameworks. So we used Backbone and a lot of other frameworks, but it was a bit too heavy for us. So we just went ahead and did our own folder structure, and that works incredibly well for us. So we have those templates, as I said, can be rendered both server and client sides. It comes with unit testing straight ahead. And what is interesting about Kraken is that we moved the logic away from our initial index.js or app.js file into the different controllers. So controllers handle routing and a lot of other stuff. And this is something that you can actually see is now also present in Express 4. So Express 3 initially didn't have that, and they actually moved it over into Express 4 as well because they realized it helps to have much cleaner files and way more structure. And I think the best 4 modules, and there is a whole lot of different modules that come with it, are Makara, Lusca, Adaro, and Kappa. Makara is used to do internationalization, localization, or specialization in your apps. Lusca is coming with a lot of sensible security defaults. Adaro is used to bring Dust.js support, and Kappa is our NPM proxy. Now, if you want to do localization, it's actually quite easy. We use key value files for that. It's not JSON, it's our own kind of format with property files. And you just load up lots of different content bundles. And you can do that on the fly, or you can obviously use Kraken to do that for you. But you don't have to use Kraken to use all of these modules. So what we do is we have a provider that just loads for various locates, and it basically provides those different values for you, which is kind of good. And the property files are not really complex. As I said, it's not JSON syntax, but it allows for some structures where you can bring arrays in there, you can define multiple values. It's actually kind of useful for us. You don't have to use this format, but I think it's actually pretty good since it also supports some more structure like subkeys. Now, if you want to use this, it actually heavily taps into Dust. So one of the good things about it is, if you switch the locale, it automatically changes the locale for you in the templates as well by leveraging the folder structure. So different keys in different languages get resolved for you, which is very handy. And you can see that down below with the header tag. So it basically just loads up the index.greeting, and index is my controller. So my localization is bound to my controller, and it just basically loads in the file for me, which is really handy for us. And if I want to use Adaro, I basically just define Dust as my view engine for Express. Obviously, I can still, as I said before, use any other view engine. It's just Dust for us because a lot of view engines try to have a lot of logic in their files, and they try to do a lot of processing for you and calculations and that stuff. And we tend to move that rather into our controller logic. So you basically have a layout, and you provide your partials into it, and what happens is it fills up the content. So nothing new, nothing magic in there. Dust comes with some cool stuff like sections, and you can provide your view context into that. So different models can be just rendered directly. And it also comes with conditionals. So not too much logic, because it's just saying, if a certain content is there, show it or don't show it. So it doesn't really try to be that smart. Now, security is something that I think is kind of interesting. Lots of frameworks come with security measurements and lots of kind of ways to make your app secure and harden it. But lots of those frameworks also don't come with sensible defaults. So they just assume you do the configuration. And quite often, developers tend to not do that. So one of the biggest features we support is prevention of cross-site request forgery, CSRF. And it basically says, if you want to manipulate my data with post request, put, or delete, you have to provide a token to make sure that it's really the app and not somebody else. Click tracking, which basically means I'm framing your website in another website, can be prevented by setting up the same origin header. It comes with output escaping against cross-site scripting and content security policy support. If you've attended last year's JSConf, you might have seen Mike West talking about content security policy. It's really awesome stuff. Configuration happens via JSON. So you basically just say, I want that feature, I don't want to have that feature, this is my setting. Or you can just go through the method calls one by one. So you don't have to use all those kind of things. Now, I already mentioned, you have to provide a token, and it's basically just a hidden input field that you provide over to the app, and then it basically validates it's really your app manipulating the data. The NPM proxy, Kappa, is very easy to install. You can go for that globally or locally. And that's basically what we use to distribute our different services like the key store, database access, logging, monitoring. And it's based on another module called npm delegate. And if you look at the configuration, it's really just a folder called config. And in that folder, you have a bunch of different files. And you can set up various environments. So you can say, this is my staging config, this is my development, this is my test environment. And it's pretty much easy to set up. In this case, you see the view engines, and you can obviously do that for all the kind of different settings for Kraken. Now, if you want to set up Kraken with, let's say, Passport, you could go and really just configure it by providing some options to it. And this is just the index.js file that you would use for that. And now, the nice thing is about that, you don't need to mess around with the lifecycle. You don't need to figure out when is my module being loaded and why. You just tap into different events, like in this case, middleware. So after my session is loaded, I make sure that I can use my Passport local strategy. I just make sure that the user is nicely serialized and deserialized, and that's it. So it provides a very, very clean way to make sure that my projects are nicely and visible. So I think it helps a lot. And since we wanted to make sure that people don't have to set up this stuff manually, it comes with a Yeoman generator. So you do npm install generator Kraken, call YoKraken in your shell, and that's it. It's really easy to set up, and I think it is pretty cool because it does a lot of scaffolding for you. So it comes with the templates, it comes with the localization, with the tests automatically, which is really useful for all of us, I guess. So Kraken nowadays is already in version 1.x, which also came with the Express 4 push. And I think one of the features that we will focus on heavily is going to be specialization, which is not going to be purely used for A/B testing, but also for mobile device versus desktop and so on. So it allows us to do a lot of this kind of logic. And, well, I can summarize. For us, it has been actually a really good ride to introduce Node and especially Kraken to the company. We have those really small teams with lots of JavaScript full-stack engineers that are able to move much faster. We can write our applications more efficiently. We have now Dust as one UI layer, so we don't have to mess around with different templates. And it was our very first big push into open source. So for us, it really helped to make sure that we are not just building proprietary software for PayPal and release that to the wild. We actually tried to figure out what would be useful for everybody. And our teams are now so convinced that all the new apps are going to be written on Node purely. Big thanks for attending my talk, and I'm open for some questions.